Well, thanks for inviting me. I'm Jim, KCØRPS, and I'm with the Edge of Space Sciences, which is a ham radio club here in Denver. And we launch high altitude scientific balloons, not hot air balloons, but weather balloon type things. And about 15 balloons a year, and we carry up payloads for student programs primarily. And those include aerospace programs from CU, other colleges around Denver, or other colleges around Colorado, and Metro State University. And then we also have some high school programs and some elementary school programs. There we go. So, Chuck, if you're thinking anything I could have for Christmas, this looks pretty cool. Lego set. Funny thing is when you tell AI to draw me something with a keyboard, the keyboard came up with this different than we normally use, but it's got an HT and a foot switch, all sorts of neat things. So we'll try that. But what I'm going to tell you about is 3 different kinds of balloons that we're involved with. Chinese spy balloons, I wasn't actually involved with them. But high altitude latex balloons, that's primarily what we do. The Weather Service balloons, and I've got some examples of the stuff that the Weather Service no longer flies here out of Denver, but maybe starting again. Pico balloons, which are the ones that go up to 45,000 feet, go all the way around the world. And the Chinese spy balloon, I'll talk a little bit about that at the end. But high altitude latex balloons. Primarily what this is a latex balloon filled with hydrogen. Helium's too expensive. Filled with hydrogen. It's the poor man's space program because we can take student payloads up to 100,000 feet, which is about 95% of the atmosphere's down below you. The sky is black. Makes for good GoPro pictures. They can do experiments. It comes down. When the balloon gets up to altitude, it pops. And then it comes down on a parachute, lands, and we recover it for the students. Here's an example of a flight string that's just taken off. Parachute up at the top here. And then our beacon that shows the position. We also have a redundant beacon down at the bottom. And we also have an ADS-B, which is the aircraft beacon that airliners can actually see and air traffic control people can actually see. It's filled with hydrogen.
What are those other things, payloads?
The other things are the student payloads. Those are all the packages the students put together. Typically about size of half a loaf of bread, weighs about a pound. Usually has a data logger in it, once in a while a radio, but usually a data logger. They collect data and then read it out when they get back to class. It's a controlled ascent. We put just the right amount of gas in it so that it goes up at about 1,300 feet per minute. And that way we can run predictions in advance, predicting where it's going to go. If it went up really fast, the wind wouldn't affect it as much as if it went up really slow. So we control the speed that it goes up at. The boom bursts, it comes down on a parachute. We use GPS to identify the position, latitude, longitude, and altitude, and then send that down on 2-meter APRS.
Sorry.
Yeah.
Apparently you said I'm not sharing the screen, so
Okay.
I want to make sure really quick that we are sharing. I apologize.
Well, he's working on that. Let me show you. This is one of our APRS beacons, the 2-meter J-pole antenna that is tied to the flight string down below, hangs from the flight string, has a GPS antenna up on the top, and they have it turned on. Okay, that was an APRS burst, and then it'll go quiet for 20 seconds so that we can send DTMF codes to it. And we can connect that up to the balloon and actually terminate the balloon flight if we need to by releasing the balloon, let it go up. And what it'll do is it'll send an APRS packet then, and then it has a DF tone that it turns on, DV, DV. So if all else fails, we can get out of direction finding antennas and hunt it that way. We have a cut down mechanism, like I said, so that if it floats into DIA airspace, for example, we can terminate the flight and we track and then recover these balloons. We've flown 382 of them so far, and we have recovered all of them. Wow. Olay.
Yeah, I'm not sure why that's not showing.
IDs itself, and now the DF tone. Chuck, you can turn that off. Okay. KE0BMV. Yeah. I think.
Echo in the roofs.
Okay, the history of amateur ballooning. Back in 1964, some German hams claimed that they did fly an amateur radio balloon. We don't know too much about that, but there were some Finnish hams in 1967 that have documented experience with flying a balloon with an amateur radio transmitter on it. In 1986, Bill Brown in Findlay, Ohio, from the family farm, launched the first amateur radio balloon that we know of here in the United States. So we call him the father of amateur radio ballooning here in the U.S. And he's still around, and we see him at the balloon conferences in at Dayton every year. And in 1990, there was a group of amateurs here in Denver, mostly from Lockheed Martin, Western Vision Network. They were amateur TV guys and trying to figure out what to do with their amateur TV. So somebody said, why don't we put it on a balloon and fly it? So that was a start in 1990. And Janine was telling me she was involved with it in 1992. So she's much older than she actually looks. Amazing. And then that group became Edge of Space Sciences and has been going ever since. I got involved with them about 20 years ago, about 2005. Okay, for the balloons, we launched two different size balloons. One of them is called a 3,000 gram balloon. It's 3,000 grams of latex. It starts out about 9 feet in diameter. You saw a picture of it at first. And as it goes on, of course, it gets bigger as the pressure gets lower. Its burst diameter is about 43 feet in diameter. So
Wow.
it gets big. At 100,000 feet, you can look up on a clear day and see it. And you watch it and all of a sudden it disappears. Oh, it burst. And then we also fly a lot of smaller balloons, 1,500 gram balloons. They start out about 6 feet in diameter, expand to about 31 feet. We put tracking beacons on them, like I showed you. We have the student payloads, and here's an example of the various student payloads that have been built. We coach them to always build them with a tube in the center that we can put the string through, and tie a knot, top and bottom. And then we have tracking and recovery equipment that we use to get the balloons to track them and get them back. I'll show you that here in a minute.
Jim,
Yes.
how much longer is your presentation?
I can make it as short as you want.
No, I was just asking because apparently it's not sharing everybody else. That's what I was asking.
You want to try it?
That's what I was gonna say, if it's okay if I see if I can share it with everybody else.
Sure.
We're not able to see it.
Yeah, no, okay. Yeah,
That's why I
we need to do that.
But if you were, if it was just almost over, it'd be, I'd really work doing it.
Okay.
Just like this.
In the meantime, I'll tell you, the STEM programs are the smaller kids there. In fact, Saturday we're launching a balloon, and what a guy in Colorado Springs does is he works with like 10 elementary and junior high schools around the country. The students make experiments that fit inside of a plastic Easter egg. And then they put these experiments together, send them in to him. He packages them together. It also includes a camera and a data logger that records the altitude and position stuff. And he also videotapes, the takeoff and the recovery and everything. And he then sends that back with the experiments to the kids. And he impacts up to 1,200 kids on one flight.
Wow.
So it's pretty amazing. I think he said over the years, we've been flying with him he's been flying with us for 10 years. And he says about 12,000 students have been involved in that. Overall, EOSS, I estimate in the last 10 years, EOSS has touched probably about 27,000 students. We also do stuff for university aerospace programs. The University of Colorado in Boulder uses it as their introduction to engineering. They go through the design process, the objectives, budget, etc. They put it together, and at the end of the semester, they fly it, or we fly it for them. And we've also supported some government agencies, LASP, the Laboratory for Atmospheric and Space Physics in Boulder, and NOAA has developed some products, and we have flown it for them. They now have learned from us how to do it, and they fly their own balloons.
So not advancing now?
Yes, correct. It's not advancing now.
Okay. Oh, I hate that type of challenge.
Well, IT is working. Your 2,000 gram balloon,
3,000?
approximately, or the small or the large. Approximately how much weight? It looks like you may be making progress there. Can you lift on the payloads? Obviously, you got to give the students
Yeah.
the size and weight budget, but
The 3,000 gram balloon will carry about 29 pounds.
29.
We can put however much we want on it, but I'll tell you, 29 pounds, that balloon goes as it takes off. It scares me. So my limit is 29 pounds. Now the smaller balloon, there's an FAA, there's some regulations that allow you to be exempt. And they say that can be only a 12-pound payload strip.
Oh, okay.
So we are limited to exactly 12 pounds there.
Do you ever cascade balloons to get more weight? Or do you just run one balloon?
I'll show you an example of one time that we've done that.
Okay.
Over the years that we've experimented with it, but okay, the flight profile, the graph didn't show up for some reason, but we'll find one later on. But here's a map of generally what a flight looks like. First of all, we have to stay outside of the DIA Class B airspace. It's a 35-mile ring around DIA. So we usually go out to Deer Trail, Colorado, because it's just outside of that ring. And then in the winter, the wind blows to the east. So then this is a prediction of where the balloon goes. Green is the balloon going up. It bursts at this point, and then red is as it comes down. So that's our estimate before the flight of where it's going to go. We used to go to Deer Trail, real nice school. And one day a couple of the high schoolers smoked in the boys' room. And janitor says how that happens all the time, except it set off the smoke alarms and it called the superintendent and the principal at 6 in the morning. And they haven't let us back in yet. So, yeah. But here's an example looking at it up in the sky. This is at 98,000 feet. There's the 3,000 gram balloon. And this woman was extremely lucky in that she snapped a picture right as it burst and caught. It has talc on the inside of the balloon. And as it burst, you can kind of see the ghost remnants of it. And when it starts coming down, the parachute comes down about 60 miles an hour initially, because that parachute doesn't have any air up there to bite into. And then as it gets lower, it's an exponential curve. It gets slower and slower, and it hits the ground going about 12 miles an hour. Okay, communications. You people probably all know this, but we use GPS. We use the APRS protocol, and GPS can be transmitted down, as well as other information can be included in the status portion of the packet. We'll send down voltages, temperatures, things like that. And we beacon on the 2-meter band. We don't use the 144.39 that the rest of the APRS people use, because at 100,000 feet, you're going to see lots and lots of signals. So we use .34 instead, and it's pretty quiet. APRS was originally developed in the 1980s by, what was the guy's name? At U.S. Naval Academy. He was a senior research engineer, and they were doing horse races, running races with horses, and they used it to track the horses on the 100-mile endurance run.
Was that Bob Bruning or something?
Yeah.
Do you know what his call sign was?
There's something
WB4D4 APR.
Yeah. I wonder if it wasn't that before, or did he get that?
No, that was his call sign. I
Originally.
believe.
Oh, so you're.
And it just happened to work well. Automatic packet reporting system. Interesting guy.
Okay, here's another example. In the summer, you'll get some air reversals up high in the atmosphere. We actually do get up into the stratosphere, and there's some air reversals. So in the summer, you'll see the balloon go up and then actually come back, and that can get pretty pronounced and actually curve back all the way into the 35-mile ring.
So is anybody
Not careful.
really fussy? I mean, you launch it outside the ring, but if it drifts into the ring, or
Well, we do coordinate with the FAA and on all of our balloons, and they track us and watch where it's going. If it were to unexpectedly go back into the ring, we would talk with them. And in the past, they have said, no, go ahead, you're fine. Or they could say, no, terminate the flight, and we could stop it. But we do have a good relationship with the FAA, and that's been worthwhile. Okay, tracking equipment in the car. What we've got, and we got some really smart guys. There's always people that are much smarter than me, but a couple of our guys developed a software that runs on a Linux computer, and this is a small Intel-based computer with a 1 terabyte hard drive in it. It has all the maps and everything in it. And we connect a GPS puck up to it so it knows where it is. And we also connect an SDR or RTL SDR software defined receiver up to it. And in there is GNU radio, which is decoding the FM signals from that, and Direwolf, which is the software that tracks APRS. And all of that's happening in the computer. And then to make it even a little bit easier, they turned the computer in the Wi-Fi in the computer into a hotspot. And so I can take my phone or my tablet, log into the hotspot that's being generated by the computer in my car. So I can have the tablet up front, not while I'm driving. I always pull over and set the emergency brake before I look at it. But the navigator can have this and be watching it as it's really happening. It's some pretty neat stuff. And what it generates on the tablet screen is a screen that shows the map. These labels are to show what's going on. But what you've got is, here's the balloon. We're actually tracking 2 balloons that day. One is the pink and one is the green. You can see the balloon shows you the call sign and what altitude it's at. And then this dotted line is the pre-flight prediction that was generated by software that looked at the wind patterns and determined where it was. And we can watch that balloon track along the predicted path. And if it's, say, 5 miles to the north of the prediction, it's probably going to land 5 miles north of the predicted location. So our folks out in the field can react accordingly. And just to be fun and pretend like you're really flying, we've got some aircraft instruments there and showing you which way the balloon is going, what the altitude is, what the climb rate is, and then information as far as where the packets are coming from, and how we're we're receiving those.
So any of your equipment freeze up at 100,000 feet, or your batteries give out or anything?
Yeah, temperature is an issue. And these beacons that we've got are made out of foam core that's been sealed up and provides enough insulation. The electronics often generates enough heat to keep things pretty good, but you do have to work on that. Students have that problem all the time. Most of them are using lithium batteries now, which survive the cold a lot better than the alkaline batteries did. But temperature is a big issue. Okay, the regulations. There are regulations that balloons have to follow. Title 14 Code of Federal Regulations, Part 101 is for moored balloons, kites, amateur rockets, and unmanned free balloons. And it says that if your payload string is less than 12 pounds.
FAA regulations under 14 CFR Part 101 cover moored balloons, kites, amateur rockets, and unmanned free balloons. Primarily.
I don't
it's your phone.
Yeah.
Key regulations include.
Oh, shit. Well, thank you, Google. That's hilarious. Okay, if it's less than 12 pounds, you're exempt from almost all the FAA regulations. There's a couple that have to do with no one piece can be bigger than 6 pounds, which I think is the size of a goose, maybe. There's a density requirement also. But other than that, you can launch. So anybody can take a small balloon now with less than 12 pounds and launch it anywhere. Don't have to coordinate with the FAA at all. We do coordinate with the FAA, just like we do with the big ones. To keep on their good side, they can watch what's going on and keep everybody safe. If it's greater than 12 pounds, then it's called a non-exempt balloon, and there's a lot of FAA coordination that goes on. We need to call them 7 days in advance. We need to call them when we launch. We need to give them a prediction of where it's going to go. We need to tell them when it bursts. But with the ADSB on the machine, that they can actually see it on their screens, they told us, you don't need to send us all that information. Just call us when you're going to launch. And then, of course, there's a general duty clause that says no person may operate an unmanned free balloon in a manner creating a hazard to other persons or their property. So that's the way they'll get you. You screw up just this much and you fly in cargo planes for them. Yeah. But that, a lot of the laws have that. But after the Chinese balloon scare, what was that, 2 years ago? The Kelly, this is Mark Kelly, the astronaut, that's Arizona senator, and Senator Budd added into the SOAR Act, which is the reauthorization of the FAA. They said that continuous aircraft tracking and transmission for high altitude balloons. So what they're saying is we want ADSB on every balloon. And they put together the law actually required that they put together a rulemaking committee. And we were lucky, we were able to get a representative from ARRL onto that committee. And he's told us a little bit, he can't tell us a lot. For some reason, the rulemaking committee is secret. But he's told us a little bit. And what they have done, this is what they would like. Every balloon, the first meeting, they said, okay, every balloon on the glass. We want every balloon to show up on a map like this. But think about it. There's amateur balloons. There are weather balloons. There are commercial balloons all flying, and you want all of those on top of this. And they said, well, yeah, we do. And he said, these people that fly these pico balloons, these little tiny balloons, he said, this is how big their beacon is. And you want us to put ADSB on this as well? Oh, we didn't know that. But it looks like, from what I can tell, the rule is going to be the exempt balloons, the less than the 12 pounds or less balloons, probably don't have to have ADSB. And The Pico balloons probably don't have to have ADSB, but the big ones, which we fly quite a bit, will have to have it. So, okay, what you've got to do is you've got to buy they made ADSBs for use on drones. Real nice. They only weigh a few ounces. By the time you put a battery with them and everything, they weigh about a pound. But look at the price. And you're going to tell a school program that you've got to include that in your school program. So other than for the big balloons, that's going to be pretty limiting. So that's a regulation that's coming up. And I put this in here because I wanted to tell you just a couple more things about EOSS. We launch about 15 balloons a year. Often it's 2, sometimes 3 balloons in one weekend, one day. But you can see the small balloons are the blue and the large balloons are the orange. One of the problems with the large balloons is the regulation says you cannot fly that through clouds. And so if we get out there to the launch site and we look up and it's cloudy, we have to abandon the big balloon and divide the payloads up into 2 small balloons. So we have to be ready to do that. And that's why things are split up. But over the last 10 years, we've been pretty busy. And looking at some of the science that we do, this is some analysis that I did. We predict, knowing how much gas we put in the balloon and knowing how big the balloon is going to be when it pops, we can estimate at what altitude it's going to burst. And so if you predict it's going to burst at 85,000 feet, then what altitude did it actually burst at? And if I look at my small balloons, that's the blue, they all seem to cluster right around where the prediction is. That green line is a perfect burst right where it's predicted. There were a few outliers here. There were some problems with weather or bad quality control on the balloon or something like that. But those big balloons, the 3,000 gram balloons, look at the scatter that we've got here, and the vast majority of them are below what we predict they're going to burst at. I don't know the answer why that is, but we're taking a look at that and see if we can get better at getting it up to the altitude. You know, the marvelous thing is if you get up to 100,000 feet. That's just aesthetically neat. We often don't do that. We often make it up only to 95,000 feet, something like that. Okay, so that's the latex balloons. Let me talk about weather balloons. This is not an amateur activity, but the fun part about it is amateurs can go out and chase them and retrieve them. The weather balloon launch is 2 a day. Used to do 2 a day from Stapleton airport area. And we'd get up at 7 in the morning, 6 in the morning, run out there, track it, pick it up, and then go have breakfast, bring it home. And that's what these are the balloons, you know, transmitters falling out of the sky. It's really cool. These are the ones that they used to launch here from Denver. Then they had some problems with not being able to get helium here in Denver. And it was close enough to the neighborhoods. The neighborhoods were aware of it enough that they wouldn't allow hydrogen. So they had to discontinue in Denver. And then with the budget cuts in the current administration, many of the other sites have gone away. There's a privatization starting, and just this morning we saw the first balloon fly here from Denver again from a private company. But what they're flying now are small beacons like this. Instead of being this size, you know, and here, this thing that stands out here has a thermocouple temperature sensor on it, humidity sensor on it, 400 megahertz, transmits once per second. This thing only weighs about 8 grams, 3 ounces. Launch this on a balloon, let it go up. The Weather Service is only interested in it up to about 53,000 feet. The balloon keeps going and keeps transmitting up to 6,000, 108,000 feet. Balloon bursts. It comes down on a small parachute, lands out in the field, and sometimes we go out there and pick them up. And what's really neat is I think Italians have figured out how to reflash the software in these things, put it on the ham bands, and put a protocol in it that we can decode. And so a group in Texas actually programmed this for EOSS, transmits on 432.675. And we can launch this thing and track it for free. You know, the transmitter didn't cost us anything. So that's really kind of neat.
So where do you get your gas? What's that cost?
We get hydrogen from air gas, commercial. It costs us about $120 a cylinder. These are 300 cubic foot cylinders. University of Colorado has a discount with the state and everything, and they get it for about $22 a cylinder. But,
How many cylinders do you put in a?
big balloon takes about 1.5. Small balloon takes 1. So
So nobody's excited about hydrogen.
oh yeah, well, we have safety protocols in place that we use, and we're careful with it. We have not had any problems with it, and we do take appropriate precautions. But this is a really simple balloon. It's a balloon, a parachute. They use 75 feet of string, and then the beacon on the bottom. They want the beacon far enough away from the balloon that it doesn't affect the temperature measurements or something. And this is the kind of data that they plot when they get it back. This is the weirdest graph I've ever seen. The temperature's across the bottom, but they're skewed off to the right. It's called a skew T plot, the skewed temperature plot. And then on here is the altitude or the pressure. And one is the temperature, the other one is the dew point. And I've been told that you can see the wind is being recorded over here or being plotted over there. But they tell me if you can understand this chart and all the detail that's in it, you can understand meteorology. I'm not up to that point yet, but I've been working on it. Okay, look at the number of places in the world. Over 1,300 upper air stations in the world that are launched twice a day. And all this information is brought together into computer banks, and then the supercomputers run these atmospheric models. There's worldwide models of the weather, and this data all fits into it. In the United States, there are 92 locations, or were 92 locations, where including Denver, Grand Junction. Denver's actually not on this one anymore. Grand Junction, North Platte, Nebraska, Albuquerque. And they launch such that it's up at the apogee at 00 UTC and 1200 UTC. And they do that around the world, such that it all that information is at the same time to go into the models. Okay, the equipment, they use a smaller balloon. It's only a 600 gram balloon. Starts out 5 feet, goes up to about 25 feet in diameter. These radiosomes only weigh 3 to, that big one's about 18 ounces. And then they have this 46-inch plastic parachute, comes down on that. In fact, the little one, they don't even use a parachute anymore. They just use the shards of the balloon that are left, and it flutters down, and apparently isn't a concern. But here's a flight profile. They were doing some experiments in Crested Butte, launching them, and some of them would come back over toward Denver. And here's me standing up here hoping it'll make it all the way to Denver. I did get two or three of them from Crested Butte when they finally made it all the way to Denver. And to track these, I use a Raspberry Pi version of the computer. Some smart guys in Australia have written a software that decodes all the different kinds of radio zones, and puts it on a map. You have to load the maps for your local area into the Raspberry Pi. And I actually set up my Raspberry Pi so it acted as a hotspot, and I can sit up front with my navigator looking at the tablet, and we go out and chase it. Here's an example of what it looks like. There's my car, and here's where it was launched, and here's where it is right now. And the red line is what'll happen if it were to burst right now. Blue line is what'll happen if it makes it all the way up to its predicted burst point and then comes down. And these lines move around as the balloon flies. And then up on top there is the next week's worth of predictions, morning and night, for all the balloons that are going to be launched from Grand Junction. So you can look at those and go, number 12, 13, and 14 look like they'll be out in the ranch lands where I can easily retrieve it. So I'll watch for those. It's kind of neat software. But here's an example of all the weather balloons that people are tracking. There's many more weather balloons that are launched, but hams are actually tracking and putting onto the internet weather balloons in the US, Europe, and Australia, Brazil, and a little bit one in South Africa. So there's a lot of interest in this stuff. And it's fun. Go out in the field. Problem is it's like 7 a.m. Normally with EOSS, we always go and get landowner permission to go out on their property. The problem is these things land at like 6:30, 6:45 in the morning. They're a little leery of going up and knocking on somebody's door that time in the morning, wake them up. So often what we'll do is just run out in the field, get it, and run back. Okay, the third subject I wanted to cover are pico balloons. These are little balloons, very light transmitters. Now the difference is this is called a super pressure balloon, which means that it expands as it goes up. And when it gets tight, the balloon is strong enough that it doesn't burst, and it will float along at that altitude. As the pressure changes with the weather, it might go up and down a couple thousand feet, or if it cools at night, it might go down 1,000 feet. But it'll float along and transmit back, and you can go around the world in 2 weeks. Fastest I've heard was 12 days. The one we launched 3 weeks ago took 3 weeks to go around the world, but I'll show you that. But that's Bill Brown, and he actually developed this small pico balloon beacon. He's holding it there in his hand. I'll show you that in a minute. But here's the pico balloons that we used about 4 years ago. They were Mylar party balloons. They started out with the ones from Walmart, but you get them from a Scientific Supply. The cheap Chinese balloons, what they are 2 circles of Mylar that have been put together and then sealed around the edge. And so when it blows up, it's not a sphere. It's a kind of looks like a hamburger bun. And it doesn't hold a lot of gas. And so what some other people did was work on a larger balloon that had gas impermeable plastic, except they charge $165 for them. So that's tough for a lot of programs. But somebody was asking about the double balloon. The double balloon issue. Here was a example of where 2 of the party balloons were tandem together to give a little bit more lift. It's a lift versus weight trade-off. So that worked pretty good. But what we're going to now are spherical balloons. Bought this one on Amazon for $7. Here's one of those $169 ones. And what we needed to do was pre-stretch them, fill them full of air, pump them up to about 0.5 PSI, about 0.6 PSI, they burst. So about 0.5, but stretch them out. And by stretching them, you get a higher altitude for no additional weight. And So that's it sitting in my shack, sitting for a couple hours at pressure. So we get those balloons, and the beacon only weighs about half an ounce. That's with antenna. Here's an example of the beacon that Bill Brown has built. At 45,000 feet, it might be 60 below zero, but this is just a bare board with the chips on it. And then 2 solar panels that generate enough power. There's a supercapacitor on the back of it, so that it can, when it goes to actually transmit, it has a little bit of juice. But you can see my hand there, and I have small hands. So it is a pretty small one. Unfortunately, I don't have an example to show you. The one I've got is up in the air, and 2 more are coming in the mail, and I haven't received them yet. But I did show you this other one. QRP Labs makes this one. It'll need an antenna, and it will need solar panels. But once it gets all programmed, you break off the computer connector here and just use that board. And what they do is this trick where you take a microprocessor chip and you toggle one of the pins fast enough that it actually it's toggled at 1.4 megahertz, and it's a square wave, so it's really nasty. So you have to put a low pass filter on it and take care of that. This has a GPS on it with a little antenna. So here was the first one that EOSS launched in 2018. It started out, went up north, came across Canada, came down here, and then kind of circled around here for 3 or 4 days and then disappeared. The thing that gets these is thunderstorms. And if you look at this, there were a lot of thunderstorms going on in this area. Circulars, it got caught in that wind pattern. It actually went down. We watched it go 10,000, 8,000, 4,000. We thought, oh, shoot, that's it. And then it reappeared the next morning, and then it disappeared for good. But that's why they call this the Bermuda Triangle. Okay, so 3 weeks ago, Thursday, we launched one, and it started out here in Fort Lupton. It went across the Pacific. Now the red are all the little dots when it transmits. It transmits every 10 minutes. And it was being received during the day, and then at night, the solar panels go dark and it goes to sleep. And so the green lines are connecting the various days. The next day it came alive, and then it floated out. The next day we got 1 or 2 little signals which are underneath that label there. And then we didn't see anything. Something is wrong with this transmitter, because when it's over the water, we don't see anything. We got 2 or 3 packets there. It got caught in a circular here for 2 or 3 days, got a few packets. But once it got over land, we got a bunch of packets. Then it went over the Mediterranean. We didn't get much. It disappeared and then reappeared over central China. It went right over Beijing, and it went right over North Korea.
I recall, don't those have to have some mechanism to turn off transmissions when it's over certain countries?
Yes, there's the firmware in there has some geofencing.
Yeah.
It turns off as it goes across North Korea. We went across at night, so we couldn't see what was happening. And it couldn't shoot us down. It's North Korea, Somalia, or something like that, and the UK.
Yeah, I knew you.
Yeah, the UK. I've heard the UK regs are going to change, and they're going to allow amateurs to fly. So that may change. But it went across Japan, got a lot of signals in Japan. As soon as it got into the water over Japan, it quit again. I don't know why. It got caught in a circular out here. It crossed the Pacific Ocean going 40 miles an hour. It's a long time to get across. So it came across. We got a few packets once a day. Then came up over here. We had a party when it reached once around the world. it went over here just off the coast of Boston. And then it went quiet again because it was over the water. We did get one signal from it south of Iceland here. That was last Sunday. Today's what, Wednesday? We haven't heard anything from it since. So, a couple of possibilities. Either the transmitter is wacky. It could have possibly got caught in some winds that took it up north. If it gets too far north, the sun angle is so low that the solar panels don't get enough energy, or it might have gone in, thunderstorm might have put it in the drink. So all we can do is sit and wait. And the prediction, I ran a prediction and it showed it going up here across and down through the Baltic countries. And so far nothing. I keep watching. Maybe tomorrow, midday, might get something, but haven't seen anything from it yet. But we did make it at least once around the world.
So you have receiving stations scattered around the world that are.
Okay, you ready for this? This is really cool. It transmits on 20-meter whisper. Okay? It transmits a 20-meter signal, and it's the whisper protocol. Now, there are whisper stations all the way around the world, people listening. You know, if you hook up a whisper transmitter to your antenna, you can measure how far your antenna is working. And it transmits a whisper packet. And when these people receive it, they put it onto the whisper net, the database. And then there's a skimmer program of Python code that's running on my computer at home. And every time it sees that whisper packet, it turns it into an APRS packet and pushes it out to APRS.FI. Okay, so we're actually transmitting 20 meters, which is going to travel a hell of a lot farther than 2 meters. Now, to get all the information of a whisper packet, all it says is your call, your 4-digit grid square, and your transmitter power. So to transmit a little bit more information, what they've done is they create a second whisper packet, and it has a fake call sign on it. There's no call signs in the world that start with a 1, a 0, or a Q. And so these packets start with one of those 3 letters, and then they have the temperature, 2 more digits for the grid square, and how many satellites it's receiving. So that stuff gets all put together into the APRS packet. So anyway, that's the current status of the balloon. At HamCon, we're going to launch 2 pico balloons, 10 o'clock, 10:30 on Saturday. One of them will be one of these 20-meter. Now, the 20-meter thing has a balloon, has 17 feet of wire, number 34 magnet wire. And then it has a beacon, and then it has another 17 feet of wire. So it's got a 20-meter dipole floating. And then we're also going to launch a 2-meter version of it. The 2-meter version will work great when it's across the United States, but as soon as it gets off the coast, about 150 miles, you're out of range for 2 meters. So you won't hear anything from it until 3 days later or whatever, when it gets across the other side. And it is, in addition to the geofencing, it'll change frequencies, because Europe uses a different APRS frequency than the US does. Asia, I think, uses something different anyway. It changes as it works its way along. Okay, Chinese spy balloon. I promised I'd tell you about the Chinese spy balloon. You remember the hoo-has that went across the United States, and they let it go all the way across the United States. I'm convinced they had jammed it so that no information was going back. They let it go across the United States, and then when it got off shore, they shot it down. Now, a balloon, you can't just shoot it down with the guns on a fighter jet, because that'll just punch holes in the balloon, but there's no pressure, and so the gas doesn't. They tried that once up in northern Canada. They shot down a balloon, it floated all the way over to Norway before it finally landed. So they decided that's not going to. So they decided we'll use a Sidewinder missile. So they got the Sidewinder missiles out. I think they had to retune them. Isn't a Sidewinder a heat-seeking missile? So they retuned them or whatever, and I think they missed with one, and then they finally hit. But they shot down the Chinese spy balloon. Here it is, shot coming down. It picked it up in the water off the Atlantic coast. But this is the coolest picture. This is a picture of the balloon, and I didn't even know they were still flying U-2s. But this is a U-2, and you can see the shadow of it there. And they fly them out of Beale Air Force Base. And there's still some that are actively flying. But the Chinese balloon, it was 200 feet in diameter, and it had about 4 kilowatts of solar panels on it, and it had fans so it could steer itself around and move. I guess they could circle around military bases and take pictures and send them back and everything. So it was pretty sophisticated stuff. But they shot that down. But in that panic, remember, there were like 4 unidentified objects that they saw, and they went and shot them down with Sidewinder missiles. And we're convinced that at least one of them was a Pico balloon. There were 2 of them that were shot down, and they kind of match up with where Pico balloons were. This one over Lake Huron that belonged to WB0 EMJ, the timing isn't quite right, so that probably wasn't his. But the K9Y0-15 balloon, I'll show you, it probably was his. What happened was it was coming across the Pacific Ocean, and this was the last location at night. After that, the solar panels didn't have enough power, it didn't transmit. So during the night, it was floating along over here. And remember, the US Air Force came up and shot one down over the Canadian Yukon. And some people did some analysis. What they did was using that position and the weather data, where the balloon probably would have gone during the night. And here's the spot where it was during the night. And then the military did say that the search, they went out and searched for the remains. They didn't say they ever found anything, but they said the search was somewhere between Dawson Creek and Mayo. So right in this area. So it was probably his balloon that was shot down. Now, he was at Dayton and talked, and people asked him a question about this, and he wouldn't say a thing. I don't know if his lawyers told him not to say anything or the military told him not to say anything, but they think that's what it was. So, so the military, has the weapons to zero in on this thing now. It's probably end my career, but I'm going to show you a classified document of the military's next weapon to take. Okay. So that's what I got for you.
I saw them shoot it out of the sky. I was in Myrtle Beach at the time.
Really? Oh, okay.
We weren't at Myrtle Beach, we're about 30, 40 miles away. And I saw this white thing floating in the sky. And I said, that's gotta be the Chinese balloon. All of a sudden we see these contrails of planes, like 2 or 3 of them flying around, circling for a little bit, probably waiting for the order to shoot the damn thing down. And sure enough, we watched the contrail with the missile.
Oh, really? Wow, that's cool.
And then our hotel was on Myrtle Beach, so we actually saw the boats out in the distance. And I got the pictures archived somewhere where I got some of the boats contributed.
Okay, so very neat. Very neat. So there's a bunch of them up there now. I have heard that NORAD actually is looking at some of these APRS stuff when they see something they're wondering about to figure out if it is an after balloon or not. That's what I got. Thank you. So the goodies over here, come and take a look. And EOSS is glad to have anybody come out. If you'd like to come out and watch a launch or get involved, ride with the tracking and recovery people. We're gonna meet people, but like to show you what's going on. We do have to launch, well, we launch at sunrise, but I don't know if that's early to pee anyway. We launch at sunrise and we launch from out east, so it's an early morning thing. But we usually finish up about lunchtime, have lunch at some restaurant out there and drive home, get home about 2 o'clock, so it's good time.
So as far as funding for the balloons, usually whoever wants to launch the package, they have to fund their own launch.
Yeah, it costs, we pay our people mileage for tracking. We're very volunteer mileage for tracking. Those big balloons cost about $500 and there's about $500 for the helium or hydrogen. So a big balloon, I think we charge $1,800 for it, and a small balloon is like $1,400. So yeah,
Is that per package or is that for the entire?
for the whole.
So it could be split up between multiple
Yeah.
groups.
Yeah.
It's $500.
But I'll be damned if I'm gonna say, okay, that weighs 7 grams, so I'll give them a call. You know, you gotta figure that out. Yeah. But it's not all schools can do it. We need to get some grants, but we don't have the people to do a lot more loans.
Right, that's still cheaper to send to the ISS than have it launched.
Yeah.
Yeah, and I know there's what's it called, Silver something, it's a school in Maryland that's launching a satellite from the ISS, I think in November.
Okay.
We're on the last supply mission. And it's gonna be taking pictures for 3 or 4 months. They're doing slow scan TV.
Oh,
Satellite.
okay. The reason I'm giving you this,
17, I think it's called.
the reason I'm giving you this is because we've got our website on the back there. You can look and see, what flights are coming up and what pictures from the flights have happened. And then there's also real-time tracking available on the web. When the balloon is flying, you can go to this track.uss.org and actually see the same thing that I was showing you was on the screens in the car. Gets shown on that kiosk, so you can track what's going on. It's kind of like watching grass grow. It's fun.
So does FCC or anybody, I can't quote chapter or verse, but there's something about what you can transmit, whether it's CW or voice or, MIDI or something. Do they care what you're?
No, we have over the years done, slow scan TV, CW, IDs, have had crossband repeaters that we've flown. I don't know how you actually work the control operator, when the balloon's up there at 70,000 feet, but I think we could probably DTMF that thing to turn it off if it was flaky, but
And so there's FCC equivalent in every little country spread around the world.
yes, yeah, the Pico balloons, right? The Pico balloons, once they go, I think there's some international treaties as far as for scientific and meteorological purposes, balloons can fly over other countries. So I guess that's what we're under. But I do have the balloon is flying and it's transmitting my call sign. So when we were going over North Korea, I was kind of wondering if some little guys in black pajamas might show up at my door. Okay.
See if anybody online has a question. Anybody online have a question? We got Steve and Bob. You guys have any questions for Joe?
There's a couple of questions in the chat.
Yeah, notice when they share the screen or light.
Yes. No, what's that all about?
That's when it's having technical difficulties. So,
All good here.
all right, cool.
Fascinating stuff.
Yeah, thanks for your time. Thank
Yeah,
you.
Hello, Jim.
Anybody got anything else I'd like to bring up before we close this evening?
Has anyone tried to grab a balloon as it's coming down with a drone?
Not that I'm aware of. Yeah, but probably could be done. Would be nice if it's floating over toward the lake.
Right,
It would be nice.
or over, fenced property or something.
Yeah, power lines.
Exactly, right.
We have tried to build done some experiments trying to build a steerable parachute. You could have like an airfoil with servos that pulled the wires, but didn't make much progress with them.
Have you ever worked with ARISS or anybody to see if we can get pictures from the International Space Station at altitude of a balloon? I think that would be looking cool.
Looking down.
Yeah, that'd be pretty. Try to time it so it would be.
We did launch, once a year, we have a Great Plains Super Launch. It's a conference. There's usually about 50 people there, and we do a mass launch on Saturday, and sometimes 8 to 10 balloons, 12 balloons. And one time we launch all at once, and one time one of the balloons got pictures of another balloon up at about 50,000 feet.
Oh, that's cool.
So that was cool from a distance. One problem with taking pictures out of the balloon, there's nothing to keep the balloon from spinning. And so you watch the GoPro videos and you just about get sick because around.
But what's cool about them is that you do see the curvature of the earth. You can actually see the full curve in the picture.
Yes.
It's my favorite.
What? It's not far.
I was gonna say, what?
No, it's not fun.
Any other questions, anyone?
So power companies, they always kind of frown on people using Mylar balloons. They say if you have Mylar balloons at your party, don't let it go outside. You're purposely sending them out there.
Yeah, well, we don't, actually, we're not using Mylar. Well, some people are launching the aluminized balloons, but we've been using the clear ones that seem to work. And when we have